Alright, so again, the two different kind of problems you're going to have, to kind of put them into, I guess, subcategories. You're going to have the one radical, which is like the first and the third problem example that I just worked out up there. And then you're going to have the two radicals, where you'll need to separate them if they're not already separate. And by separate, I mean one on one side of the equal sign, one on the other. And then pretty much the radicals go away. Going back up to the one radical. First thing you need to do is you need to isolate the radical, which even in these steps it talks about that. So going through this first example, if I need to isolate the radical, which is that right there, what is the first thing I need to do? Do what? Subtract 3. Okay, I've got to get the radical by itself. So just because it's got square root on one side, don't automatically think that the first step I'm going to do is square it. You might have to move stuff around before you do that. Next step says to use the inverse operation. All that means is the opposite operation. So opposite of square root is squared. So I get x plus 13 equals 25. Next step says to simplify. This is the part where you may have to factor. If you get x squared, then that means you're going to have to factor it. But you simplify it and you solve it. So on this one, x equals 12. And then you'll check for extraneous solutions, which we'll talk about that here in a little bit. Okay, so going over to example 2, you've got the two radicals. And it's got the first step up there. You need to separate them. So it's one square root minus another one. I can add that to the other side just like it's a term. So they're just going to equal each other. So I've got the square root of 5x plus 3 equals the square root of 3x plus 7. And remember, these should be easy ones, because to get rid of the radical, I got to square it. Well, I got to do it to both sides, so both radicals are gone.
Just because as a subtraction time, that's why I did that.
Yep. So I've got 5x plus 3 equals 3x plus 7. And then I would just solve for x. So x equals 2. So next, I want you to attempt here is the answer to number 1. 1 second. You should have gotten 11 on it. And the answer to number 6.
Wait, really?
Alright, so going to number 2. What's the first thing, Miss Williams, that I'm going to need to do, Carrie?
Get rid of the radical.
How do I do that?
Square.
Alright, I'm going to square both sides. And then Chance, what am I going to need to do there? How do I solve? Set it equal to 0. Aaron, what tells us that we need to set it equal to 0? Because there's what in the equation? No. because there's a squared. There's squared, that means if I'm having to solve this, I've got to set it equal to 0 and factor it. What factors of negative 16 add up to negative 6? Do what?
I'm thinking of like
Negative 8 and 2. So what two solutions is this going to give me? 8 and negative 2. Alright, so now we need to check to see which one of these is going to be considered our extraneous solution. Alright, so what I want is, Lily, will you plug 8 in for that x right there? Let's see what that right side of it equation gives you. Trey, will you put negative 2 in there and see what it gives you? Everybody else kind of look up here. If Lily plugs 8 in for x here, what should this equal? 8, because all that's over here is x, and she's putting 8 in for x. Okay, so to check it, you put the values that you have, 8, in for both x's to see if this gives you a true statement. Okay, which, Lily, what did the right side give you? 8. So whenever she plugged 8 in for x, it gave her 8. And so 8 is true. Okay, who was doing the other one? Trey? Whenever Trey plugged negative 2 in on the right side, what did that give you?
negative 5.3.
Let's look at that again. Let me see how you put it in. Okay, so whenever you plug negative 2 in, that gave him positive 2. Does negative 2 equal positive 2? No. So that is your extraneous solution. And how I have it written up there, if there's not a blank that says extraneous solution and a line for you to put it, that right there is enough for me for you to identify which one is extraneous, which one is not. Okay? Yes? So make sure that you know. We're going to talk about how you can find the real one on the graph in the calculator, but you need to know how to find the extraneous. Come test time, you'll be asked how to find the extraneous, and that's how you would do it. So up there where it says to define it, it is the solution that makes the original problem false.
False.
Yes, not true. Because
It is true.
negative 2 does not. 8 does equal 8. That's the real solution.
Oh, the extraneous is
Yes.
negative 2?
Yes.
Oh, gotcha.
Extraneous is the one that would make it false. So think of it, and don't think of it as extraneous as this new
Extra?
crazy word that's in your vocabulary. It's got the word extra in it. It's the extra solution that isn't going to work. Alright, so let's go through 7. So, Andy, what's the first thing I need to do?
7 equals 0.
Nope.
Oh, square.
Square it. Okay? So whenever I square it, now don't write this down yet. Is that correct? No. Okay, why not? What do I need to do to that left side?
Isolate it?
Square the whole thing. Okay? You do not need to see that as okay, I have 2 x's and I have 2 negative 1's now. Alright, you have 2 x minus 1's. So that involves FOIL. So that gives you x squared minus 2x plus 1. And then now, Andy, now what do I do to solve this? 0, what am I going to do?
Combine
Like
like
terms.
I'm going to subtract x squared, and then what happens? both of them cancel out. Well, so now do I have to factor it anymore?
No.
Okay. So I'm going to kind of go off to the side now that I'm kind of got a different mindset now. I know I'm not going to have to factor. Come over to the side. I subtract 1. I divide by 2, negative 2. And I get that x equals 0. Now, whenever I plug that in, whenever I plug that back in, on the left side, so on the original problem, what is 0 minus 1? Negative 1. What is 0 squared? 0. What's 0 plus 1? So I end up with that. And this is kind of a tricky situation. I'm going to do my best to explain it. Don't get too worried if this kind of lands somewhere up here on you. But is that a true statement? Is the square root of 1 negative 1?
Yes.
Yes. Technically, yes, it is. Okay? Because, you know, back it was lesson 10.2, we said that the square root of a number is plus or minus the square root of that. The square root of 16 is 4. It's also negative 4. Because 4 squared is 16, negative 4 squared is 16. But whenever we talked about that in 10.2, whenever we talked about the parabola, and then we reflected it, we talked about getting rid of all those negative x values so that it would be a function. Because we had the vertical line test, didn't work, wasn't a function, but we needed it to be. So we got rid of those x values. So because we're dealing with the square root, we don't want the square root to give us a negative answer. So whenever I'm checking this and I see that it says the square root of 1 is negative 1, even though that is a true statement, kind of think of it as within the world of square root functions, that is going to be my extraneous solution. And since that is the only solution, your answer is no solution. Okay? Again, if that landed somewhere about a mile above your head, all that, don't worry too much about it. Okay? You're not going to see that situation a whole lot. Whenever you square that left side, you should end up with x squared minus 6x plus 9. And that's going to be equal to 30 minus 2x. Here is that equation set equal to 0. Whenever that is all factored out, you should have gotten that the two solutions are 7 and negative 3. Did anybody find already which one of those was extraneous? Negative 3. Okay, negative 3, whenever you plug that in, that gives you 6. 6 equals negative 6, which is false. Whenever you plug in 7, that gives you 4 equals 4. Now, kind of stop where you're at real quick because I want to clarify this, because this problem has come up on my other 3 classes, and I want to make sure that we're clear on this. And I think a lot of it has to do with number 2 was the first problem that we kind of did. So, on 2, Lily plugged in 8, and she wanted it to equal 8. Okay, so why is it whenever I plug 7 into this side, I want it to equal 4? Do what, Morgan? Because of the minus 3? Okay. So, up here, we want it to equal 8 on 2 because x was the only thing on the left side. Okay? It's not the only thing on the left side of the equal sign on number 3. There's x minus 3. 7 minus 3 is 4. So, you're not plugging in x wanting it to necessarily equal what the value of x is. You're plugging into both sides of the equation to make sure that the whole statement is true. 4 does equal 4. Negative 3 would give us negative 6 equals 6.
Oh, so I'm plugging into the first term?
Going down to 4. Real quick on 4, what's the first thing that I need to do on this one? isolate. So I need to what? I need to add x first. This one's actually a little bit easier than that last one, I think, because you don't have to do FOIL. You just end up with x squared over there because there's just one term. So that should get you started on that one. On 4, whenever you plug it back in, you need to plug it into, you can plug it into the original if you want, but now you're just going to make sure that it equals 0, because there's no x over there. Alright? So you could plug it into that one, you could also plug it into that one.
Wait.
You just got to make sure that the statement is true. Okay, so if I do this one, if I plug 5 in there, everybody kind of follow me here, 7 times 5 is what? 35. 35 minus 10 is? What's the square root of 25? 5. So that side gives me 5. That side's just 5. So 5 works. Whenever I plug in 2, what is 7 times 2? Minus 10. The square root of 4. 2. So that side gives me 2. That side gives me 2. So do I have an extraneous solution? No, both work.
I have a question.
Alright, so now make sure that you're doing 8. If you've done 9 already, it's the easy one. You should have gotten -2 on that one. I'll go ahead and give you that because we'll be running out of time. We'll need to hurry up and get to the back. Sorry, on number 4, it doesn't change the answer. I just wrote it in there wrong. That should have been minus 7x plus 10 right there. So if you're writing it down, I made the mistake right there where it's highlighted. Here is number 8. So again, I'm going to need to square both sides. So on the right side, that's going to give me x squared minus 8x plus 16. And there it is, simplified. So what factors of -4 is going to add up to +1? Do what, Morgan? -3 and +4. What 2 solutions is that going to give me? Which one is my extraneous? Do what? So on that one, both of them are going to work. I can tell you right now that probably about 85 to 90% of the time, whenever you have 2 solutions and one is extraneous, it's going to be the negative one. Not always, okay? You've got to check it. So you have all those solutions, all those answers there. I'm going to pull up the little calculator on my screen. I'll have to clear all this out though. A way that you can check this, and I'm just going to do a couple of them, so make sure you're paying attention here. So let's look at number 2. What you can do is you can put we'll go ahead and do this one. That's 8. So if I put those in, let me do this real quick. Okay, so there is the square root, and there's the -x plus 4. We found 2 solutions and they both worked. How many times are those crossing? Twice. This one right here is close, but it is crossing. And I can do second trace 5. If I don't really want to solve it all the way out by hand. Alright, 3 was one of our answers. What was the other one? -4, wasn't it? Okay, that's where that intersection is. If I do number 2, so I've got the one side is x, The other side is the square root of 6x plus 16. On this one we found two solutions. How many times do they cross?
Once.
It crosses once. Okay? So that means you're going to have one extraneous. Now on that one, what was the real solution? Which one worked?
8.
8. Okay? So you can find that on the graph. You cannot find your negative one. Okay, what was it? Negative 2 maybe? Okay. There's no intersection there. One way that you can find that, if you want to do it on the graph, and this is more to check it. Okay, if I go to 8, it's 8 all the way across. Okay, both sides are equal. The left side gave me 8, the right side gave me 8. Whenever I go to negative 2, one side gave me negative 2, the other side gave me 2. Okay, so it wouldn't
Does it pass, there's no extra.
so it wouldn't work. Do what?
If it doesn't pass ever in the graph,
Then there's an extra. Oh, then there's no solution. So let's look at 7. 7 was the one that, and again, we won't see many like 7. But if I was to plug that in, if I get a weird answer and I think, I'm not for sure about this, I want to check it. Okay, those end up being parallel, so they never cross. Alright. So let's quickly go to the back. We're just going to look at the first problem. It won't take very long. A lot of these word problems, they are simple, and I think because they're simple, especially come CBA time, they like to put some long, stupid story to try to make it a little more difficult. Okay, and that's exactly what this one does. You've got the speed, which is represented by S, and the distance in feet, which is D. Ooh, D. Okay, and that represents that whenever a car is traveling at a certain speed and brakes are applied, this equation gives us the distance of the skid mark on the pavement. Okay, and it's by this that equation right there. S equals the square root of 30FD. And then it gives us the third variable. This is the part that they're just trying to make the problem harder because it says that. Well, down here in A, it tells us what F is. So we're not going to deal with the square root of 30 times F times D. What is 30 times 1/2? 15. So actually, the equation that we want to deal with is that right there. Okay. After that, it says Sylvia, some lady that gets pulled over, told the police she was traveling about 30 miles per hour. Is that speed or distance? Speed. Alright, and then it says the brake, she was going 30 miles per hour, braked, skidded on the concrete. The length of the skid was 195 feet. Is that distance or speed? Distance. So I've got two different pieces of information. So it would be helpful if I also had the inverse of this equation.